Welcome to Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. It's my pleasure to welcome Vinayak Dravid, the Abraham Harris Professor of Materials Science and Engineering at Northwestern University. Vinayak serves as the founding director of both the Northwestern University Atomic and Nanoscale Characterization, or NUANCE Center, and the Soft and Hybrid Nanotechnology Experimental, or SHINE, resource, which is a user facility that is part of the NSF-funded National Nanotechnology Coordinated Infrastructure. Vinayak, thank you so much for joining us today. Can you tell us a little bit about yourself and how you got involved in nanotechnology?
Nice to see you, Lisa. I'm delighted to be part of this interview and the podcast. So my name is Vinayak Dravid. I'm a faculty of material science at Northwestern University. And much of my training, right from the inception graduate school at Lehigh University, everything related to research education has been in the area of electron microscopy. So naturally, I've been looking at very small objects because electron microscopy is looking at atomic and nanoscale structures and phenomena. And that's where my training was derived in from Lehigh. And as I joined Northwestern University, that has been in 90s emergence of the early stage of nanotechnology with a number of colleagues involved in structures and processes at that scale. And that's how we got involved into nanoscience and nanotechnology research.
Can you explain a little bit about your work dealing with pollutants?
So some years ago, as we were examining nanoscience and nanotechnology in various capacities, we've been doing basic science, making impact in the areas of energy, environment, in terms of fundamental phenomena. I realized in order for our research to have impact, we also need to translate the nanoscience into nanotechnology. And I often say that the translation from science to technology is a bridge of engineering. And so I wanted to make sure that any scientific insight we have has the potential for scalability. And that's where we came up with this idea of sponges and membranes, because by themselves, there's almost last year, for example, 500 million tons of sponges were disposed and discarded as waste. So imagine, instead of throwing it as a waste, if you can add value to it and use it as a way to remediate environmental pollution, then you get best of both. You reduce the pollution in the first place by not disposing them and using them in a repeated way. And so what I'll explain a bit later is this technology is called the story of R.
Can you talk a little bit about the target pollutants that you are exploring, or is it really effective for a wide variety of remediation applications?
It's an excellent idea. So one way to think of this is, it's been almost 2.5 centuries of industrialization, especially in the Western hemisphere and the Western societies. And in the past, it was all about technology acquisition or the cost. And there was not much consideration on the aftermath or the burial of materials and technology. So there's been a legacy of 2.5 centuries of pollution that has accumulated in our society. And a lot of it is oil-based, because the fossil fuel were used for both transportation, but also for plastic and petrochemical. We have nutrients. That's another area where fertilizers, a lot of fertilizer runoff into waterways. So the pollution over the years, over the centuries, has accumulated in many categories, oil being one of them, nutrients in another, microplastic is another. So we are looking at technology which is the ability to scale and capture this in a very preferred manner. And that's where we came up with this idea of OHM, or Pearl technology, as a thin coating that can absorb pollutant only and not anything else. So we call it the story of R, because you use a very thin coating, so you reduce the material. Secondly, we recover the pollutant, so it's the second R. We reuse the same sponge again, so you reduce the waste and inventory. And in some cases, just like a household sponge, once it starts to getting degraded, you can recycle it. So that's recycle. And then in the process, we restore the environment. So we reduce, we reuse, we recycle, and then we restore. And that is the concept that we are applying to environmental remediation.
Wow, that's very exciting. I'm going to switch gears a little bit and ask you some questions about your center. So, can you describe both Nuance Center and the Shine resource and what they enable?
So if you look at now, just to take a step back, before just about mid 90s, internet came, web, and this tremendous connection throughout the world. And that's when, if you start to look at what is the role of universities, research universities particularly, that is about the time where the Bell Labs was going down, the Watson Research Lab. So there is this sort of vacuum that is created between innovation and translation. And now a lot of the research universities are now picking up the mantle of innovation. So in the past, we used to say that universities have two products. We have students like you and others, and the other is intellectual property, papers and patents that we publish. But now there's a third pillar that's emerging in the last couple of decades, which is infrastructure, facilities. Even large companies are reluctant to invest. And you see the technology, science and technology is getting more complex, more sophisticated. So you need the tools and techniques and methods to examine, to fabricate. And that's where I think this realization occurred. And the program that you're referring to, NSF program, whether it's National Nanotechnology Initiative or NNCI or Quantum, a very important component of these is facilities infrastructure. We attribute Richard Feynman to many quotes. One of his quotes is, if I don't see, I don't understand. So this ability to watch and see nanostructure really revolutionized our ability to manage them. And so that's the component universities picked up. So Nuance Center stands for Northwestern University Atomic and Nanoscale Characterization Experimental Center. It came from the recognition there are many needs in a research community like Northwestern or region in Chicago, where you need electron microscopes, spectrometers, and other capabilities, which you may need only once a week, once a month, a few times. And large companies need it, small companies, university professors, and there's an important education component to it. So if you look at research, education, and outreach, because these instruments, methods, technique, visual appeal is one way to attract students, especially URM and others, to underrepresented fields such as STEM fields. So having a capability that can be showcased to the student is also another exciting. So all three aspects, research, education, outreach, require this centralized or coordinated infrastructure. That's when Nuance started. And then we realized that Nuance represented certain capabilities in characterization. But there are many other needs, especially in the Midwest. We recognize that we have agricultural industries, we have research and other programs related to food, water. We are a part of Great Lakes Consortium. And we realized that that particular area has been missing from a lot of portfolios between soft and the hard interface. So soft material like biological, NIH, and other programs are there. For hard material, there's DOE and DOD and other. But when you make hard and soft interface, it's at a very unusual area because soft materials are dominated by fluctuation, hard are very rigid. So capabilities to make structures, analyze them in this interface has been a real challenge, and that's what led to the SHINE resource. So we proposed in 2015 an idea that we can have a consortium of facilities, capabilities between Northwestern, U Chicago, and our surrounding region that can serve this very unusual need of both researchers, but also educators and folks who want to bring folks into research arena in this area of soft and hard and hybrid interfaces. So SHINE started as an offshoot of Nuance to expand into soft and hybrid nanostructures.
So you covered so much in that description, and I think of these facilities as being innovation platforms. And we recently did an OECD study that actually used the network of facilities you're part of, the National Nanotechnology Coordinated Infrastructure, as a case study in looking at exactly all the things that you just mentioned and the impact on students and industry and research. So one thing you hit on I'd like you to explore a little bit further, and that's the concept of interdisciplinarity. So how do you see the facilities impacting interdisciplinarity, and how do you see the impact of interdisciplinarity?
Oh, absolutely. Excellent question. And because that is one of the major challenges we faced, I say 25 plus years ago. In the past, the fields were evolving within themselves, metallurgy within metallurgy, chemistry within chemistry, physics within physics. But what nanotechnology showed is that you can bring in people with different background, disparate expertise, and address a core problem. So let's look at energy, environment. These are problems which are not limited to one discipline and one set of expertise, correct? So you have energy. Within energy, there's a supply side of energy, there's a demand side of energy, there's a policy side of energy. So as a result, I think it is necessary to bring together people from different technical background, but also other development, other expertise on the policy and global issues. And those are the sort of a concept that really help together the interdisciplinarity. I'll give two quick examples. So one would think that journalism would have so little connection to STEM fields. Correct? Journalism is an entirely different topic. But journalism is an important parameter for the society because that's one way society learns about development in other areas, right? And so now with the science and technology becoming so complex, it's all the more important that journalism and the journalists know the complexity and the elegance of science. So we have a program where journalism students spend time in Nuance and Shine facility to watch how creativity works. So these are students who are not technically savvy, they're not technically trained, but they are trained in human interactions. And so they connect with the users of a facility, quiz question, ask them about why are you doing this? Why is it important? How is it relevant? And they take this complex information and put it in the bite-sized reports, blogs, and that is a very important parameter. And you can imagine that most of our research is supported by you and I, taxpayers. So we want to convey the beauty, elegance, and the relevance of science and technology. And what better way than to have journalists convey that? And the reverse is equally true. So in this process, scientists, engineers who are generally not as effective as communicators learn how to tell stories, and then they learn that aspect from the journalism. So that's one aspect that you can see how something very obtuse such as journalism has such an important relevance. And the reason being that the way the fields have evolved now, there are implications on ethics, on moralities, equity, and many other considerations. And there is an opportunity for science and technology to fill those gaps which were present in the past. So these are some other examples. One other very quick one that I can tell you is we have a very strong outreach program with the museums. And especially Chicago, as you know, has fantastic museum of science and industry, field museum, art institute. So art particularly is an example where we initially started with analysis of arts as a way to help curate, because there are a lot of artists, we don't know much about what material they use in pastels and colors. How do we preserve this societal treasure, right? And so we started that program, and then Mellon Foundation realized that this is very exciting, and then we got a research grant that allowed us to collaborate more actively. And you can imagine that if these are exhibits in Art Institute, which are seen by millions of people, and so it is through that mechanism we can get exposure to masses and the society and get them to appreciate the beauty, elegance of science and technology. So it's not a single silver bullet, as you know, but multiple things. And this is one of the very exciting things we're engaged in, is societal outreach through museums, for example.
Well, those sound like great programs, and I'm definitely going to take a look at your website and see what I can find. I want to switch gears and talk a little bit about nanoscience and nanotechnology. And this is a question we ask all of our guests, and that is, from your perspective, looking back over the past 20 plus years of the NNI, what do you think are some of the most exciting advancements that have been made? And then looking forward, where do you think the most exciting opportunities are?
One answer I often give, it may come across odd, but I think one of the main thing I personally feel nanotechnology or this field of nano X has done for us is ability to be audacious. Our idea of pulling together disparate disciplines, different ideas under one umbrella. Because the problems that we often deal with, energy, environment, life sciences, like pandemic is one splendid example. These are global problems, right? And you need ability of multiple disciplines to come together. So I think personally, nano help bring together disparate groups from science and technology to ethics, journalism, and many other areas. So that's one. Secondly, I often like to call 3 areas of nano. It's called as nano-enabled, means nano has enabled something. Nanocentric, so that the core science technology of phenomena is nanoscale centric. And the third I call is nano peripheral. That is, nano is a way by which you're bringing other things together. So let's look at the nano enabled. That is the most impact it has had for the last 20 plus years since the inception of NNI, is without changing significantly a process, phenomena, structure, how do you add value? So one very important example is pharmaceutical. A large number of pharmaceuticals are not aqueous. They are not water-based. And because most of those drugs tend to be hydrophobic, by just a simple process of making them small, increasing surface area, you improve their ability to dissolve in water. That might sound very trivial, but you can imagine that's one major area immediately. So you didn't have to do anything extra, no additional processes. You just make structures smaller, as an example. The second area is in the form of coating and surfaces, right? So there are a lot of companies and small companies, large companies, which are enabling functionality by just invoking the nano in the form of structure, nano in the form of phenomena. So there's a range of nano-enabled products and systems that have emerged in the last 20 years. And the nanocentric areas are really picking up the carbon nanotube-based transistors, the electronic, electron-optical, the kinds of work we do in environmental remediation, we feel is the nano-enabled, because the true core of the technology is the ability of these structures for affinity for pollutant that is derived from their size and the behavior at that scale. And the third thing I call nanoperipheral, because by pulling together, say, Cancer Center for Nanotechnology or Nanoscale Science and Engineering Center, which is one of the early large centers, we bring people together from different disciplines and use nano as a rallying cry to bring people together. So those are the three areas I think it has this amazing impact. And that has morphed into other areas. So today we talk about quantum, which is great. And quantum is anchored by a lot of the infrastructure that we made in the nano. So this nano provides us the gateway all the way up to almost the door of quantum. And then within the quantum, there will be need for specific initiatives, specific capabilities, program, and we support that. But we already have a nice guiding pathway towards that through nanotechnology initiative. And so what you and your colleagues have done has really has a lasting impact, not just the American infrastructure, but the world nanoscience.
I really like the way you phrased your three categories, then also the relationship with quantum, because I think that's one of the things we talk about a lot is how is nanotechnology and quantum information sciences connected. So that was a great description. We were recently contacted by a high school science teacher who uses these podcasts in his class. He teaches a class on nanotechnology. He has a tabletop SEM that he uses in his classroom. And he encouraged me to always ask this question, and that is, what advice do you have for students that are interested in pursuing nanotechnology in some way?
There are two answers to it. One is a more generic answer in general for anyone who's pursuing innovation, science, and technology, or any field, journalism, is to ask questions, be curious, and ask question why. And often in this Twitter age where 20 seconds is the limit of patience sometimes, I think that's a very important trait to have, is take a step back, ask question, go deeper into a problem, look at it from different angles, because you might come with a specific perspective which may be just purely science-based. But many times you need to look at the societal aspect of it. And there are many examples I can give you where by doing certain things in Africa, people thought that it would be only about charity, but it turns out that we learned a lot about supply chain, what happens under resource-limited situation. So my advice is ask question, go deeper into the problem. Secondly, get breadth, because you want this combination of depth and the breadth. So we need domain knowledge, very important. So clearly, ability to go deeper into a subject matter is very important. But let's do that in the context. So there's no point in solving a problem that not many people worry about. So we want both. You want a problem that is pervasive, but at the same time, there are orphan problems that you may need to, because a small cohort of society might suffer from it. So we don't want to leave them aside. So you want this ability to go deep and broad at the same time.
I think that's great advice. And I want to thank you again for being with us today. And do you have any final thoughts that you'd like to share with our listeners today?
I think being audacious, as I mentioned, be ambitious, aspirational. I think the world is integrated. In the past, we used to have competition between Northwestern, MIT, maybe, or Stanford. But now world is the marketplace. Perhaps the universe is the marketplace. Now we are going to Mars and Moon. And so I think to think boldly, aspirationally is the way to go.